Wait, guys. Let's push. So we've got in this question they say probability of A, that is B and B, right? Cool. The first question is saying what's the probability of not B, right? I would start with the formula. You guys know that. So the probability of not B is 1 minus probability of B. This is the formula that we use. And remember, in the first video we termed this, or we classified this or categorized this as complementary events. Yeah. So that means our answer is 1 minus 0 0.5, which is 0 0.5. Right, cool. Then remember, for this one the formula is probability of A plus probability of B minus probability of A and B, right? Which when we substitute, we're gonna have 0 0.4 plus 0 0.5 minus 0 0.25. 225, right? And the answer is 0 0.4 plus 0 0.5 minus 0 0.25, which is 0 0.65. I think it makes sense. It's 9. Yeah. You see, cool stuff. So you see, though, the thing is, let me show you. The first one, it was just 1 mark. The second one, 2 mark. I mean, it's fair. The third one is 3 marks, right? That's the first thing I want you to be aware of. Number 2, when I look at this, man, probability of not A and B, that is quite confusing. For me, at least, like when I look at it, I'm like, oh, what are you talking about, right? So what I can then do, I mean, of course, you can then use Venn diagram. It sort of helps, bro. It sort of helps. So let's try to use Venn diagram here. So for Venn diagram, of course, I have my rectangular square. I have, oh, that was a perfect circle, right? So I will say this is A and this is B. Yeah. And the end, this is 0 point. Okay. Let me just write 1 over 4, right? 1 over 4 is for 0 0.25. And this is of course going to be what? 0 0.4 minus 0 0.25. This is going to be 0 0.15, and here 0. This is going to be what is it going to be? It's going to be 0 0.5 minus 0 0.25. Oh yes, of course, it's gonna be a quarter as well, or 0 0.25. Right, cool. And let me add all of them. So it's 0 0.15, no 0 0.15 plus 0 0.25, that is for the intersection, plus 0 0.25, and that is for this one. It's giving me 0 0.65. I mean, here it is, right? And then that means, what do I have? 1 minus the answer. On the outside, I'm gonna have 0 0.35. Then my Venn diagram is complete. The reason why I'm saying this, it helps, right? This is how you can answer it. So the same probability of not A. So this is A, right? So that means the square for A has already been cancelled, right? And this includes two things, right? If it was a probability of not A, our answer was going to be 0 0.35 plus 0.25, these two, right? If they were just looking for probability of not A, right, we get 0.6 by adding these two. And of course you can also get it by saying 1 minus the probability of A, which is 0.4, you still get 0.6. Now, and when we add the two, we still get 0.6. That's probability of not A. But they say probability of not A and B, right? So we have the not A, we are fine, and now we have and B, right? So when they say and B, it excludes or eliminate this possibility of 0.35, and the only value we have is 0.25, right? So in your answer, you can do one of these two things. Ne? You can draw a smaller Venn diagram and cancel out the A event and cancel out the 0.4. Do mention it that event A is cancelled and 0.35 is also out, and the only answer you have, which is 0.25, that's the probability that is left, which is the probability of not A and B. Or you can do this now from the probability of B. When they say not A, you can take probability of B and remove the A portion, right? So the A portion is this 0.25. So you can then say that wait, what's happening, bro? Come on, nigga. Hey, bro, what's happening with this thing? Okay, cool. Yeah, so now that means here you can say your answer is going to be 0.5. Remember, the 0.5 is for probability of B, and we are subtracting any part that has A in it, right? That is going to be 0.25, and it's the intersection, right? And you get your answer 0.25, which is our value, the one we didn't predict. We showed that the answer would be that. So yeah, cool. Let's jump to the next question. So the second question, they say, so in a school of 70 kids, 70 grade 10 learners, 32 takes economics and 43 takes mathematics, 15 takes neither, and let X be the number of learners taking both. Do you understand? So they say show that X is equals to 20. I want to say for the first question, show that, look at what's happening here. They say show that X equals to 20. Then they say draw the Venn diagram to illustrate the above information. So it seems like for the first question we don't have to do the Venn diagram, but I want to say the truth. I want to admit this. I myself, I will most probably do a mistake if I try to solve the first question without a Venn diagram. So I don't want to lose marks, so I'm gonna draw my Venn diagram, because I know my mind is powerful, but not that powerful, right? So let me do my Venn diagram. So I'll just do my smaller Venn diagram and my two events. Not a perfect circle. Cool. So what thing I know, the number here is X, right? I have economics, I have mathematics, and they tell me that the number, so S is 70. That's the number of learners I have. And then number of kids taking economics is what? 32. So here I'm gonna write 32 minus X, right? Because the whole cycle of economics must add up to 32, right? And then here I'm gonna have 43 minus X. Do you understand? Then 15 learners take neither of these subjects, right? So that means I have 15 outside here. You see, with this picture now, with this Venn diagram that I have, it becomes way easier for me to solve for X, which is basically what they're asking me to do. Because then I can say 70 equals to, remember 70 is the number of people that are there, the number of learners, right? So if I add each and every number in each region, I must get 70. So that means 32 minus x plus 43 minus x plus 15. Now, and already I'm seeing this, I'm gonna add up to 0. This is negative, so I will transpose it to the other side, and then I will transpose 70 to the other side of the equation. Right, so yeah, let me do that. I have x equals to 32, this is 0, x, this 2 is 0, plus 43 plus 15 minus 70. Right, therefore 32 plus 43 plus 15 minus 70 gives me 20. You see, now it was so easy. It was super easy for me to get the values. Né? Cool. So on the second question, when they say now draw the Venn diagram to illustrate the information above. So with this information now, what I will do is I will delete. I want to bring this closer to say that is x, right? And I want to copy this guy. I want to copy the gentleman and paste him here. All right, and I'll say that is number 2, right? So remember x. So now what I will do is 32 minus x, which is, remember x is 20, né? So it's 12. So here I'm gonna write 12. Né? X I'm gonna write 20, and there we have 43 minus 20, which is x. I have 23 and I have 15. So remember, the idea must still be the same. If I add all the numbers inside, I must get 70. If I don't get 70, I am wrong. Né? So let me do that. I have 12 plus 20 plus 23 plus 15, 70, saying that I did nothing wrong. Everything is still fine so far. Right, that was number 2, where I drew the Venn diagram. And then now it's me answering questions based on the Venn diagram, of course. Determine the probability of a learner taking economics and mathematics. Bro, they gave us the answer, you know, on the first statement when they told us information. That is 20. So for the first one, you're going to have 20 over 70. Right, that's going to be your probability. Right, the second one, they say at least one of the 2 subjects. So they're saying that, yeah, okay, determine the probability of a learner taking at least one of the 2 subjects. Right, so that is English. Né? Most people would get this question wrong because of English, right? And once you can see through it, you have it. What are they asking for? Are they asking for a particular probability? No. Are they asking for probability of A and B? Maybe. Is it A or B? Maybe. What does the English say? At least one of the 2 subjects, meaning it could be economics or mathematics. Right, so it's the or that they are talking about. Right, they are asking you the probability of or here. Right, find the probability that the learner take economics or mathematics. Right, that is the probability of taking at least one of the 2 subjects. Right, and you know that the or is basically all the circles being shaded, right, which is going to be, you have 12 plus 20 plus 23 over 70. Right, or what I will say is try to find the solution via the normal way of calculating or, right? It's going to be probability of probability of A, which is 32 over what? 32 over 70 plus 43 over 70, and then we subtract the intersection minus what? We just calculate. Oh, that is 20 over 70, right? This is you finding it via the normal way. We are getting, let's note it down, you are getting 11 over 14, which is 0.787979, right? And let's come back here. So say you say 12 plus 20 plus 23 divided by 70, you are getting 11.14, which is what? 0.79. Am I going somewhere with you? I hope I am, bro. I hope I am. So taking exactly one subject. So now I say determine the probability that the learner is taking exactly one subject. Right? So this one is just, there is no formula for it, but it's there. It's there. Remember, 15 is the people taking none, right? And then 12 is the number of people taking only economics, one subject. 23 is the number of people taking only maths, one subject. So what do you think the answer is going to be for number 3? Ne? Think about it. The answer, you are right. It is going to be 12 plus 23 divided by 70. Right? Then you round it up because it's 12 economics only, 23 maths only. Then boom, you have your answer and you are done. You are done, friend. So the next one, they said the probability that a learner, the probability that a mathematics learner is also a physical sciences is 79%. Determine the number of learners taking. Beautiful. Right, so here let's listen to English. The probability that a mathematics learner is also taking physical sciences is. So here they're saying probability of maths, that probability of maths and physical sciences, which is probability that a learner takes both maths and physical sciences, is 0.79. That's what they're saying, right? And that's what they're saying. So what is that saying to you? Let's think about this one. Right, let's think about this one. The question is, what are they saying? Remember, in total, in this grade 10 class, in a school of 17, yeah, so we have 70 learners, ne? Yeah, we have 70 learners. So the thing is, now they say the probability that a mathematics learner, so we already know that we are talking about a learner who's doing mathematics. Question is, how many learners are doing mathematics? We have 43 learners who are doing mathematics. Cool. So of the 43, right, they say 79% does what? Does physical sciences. Right. So what does that mean? Eh? That means what does that mean? That means if I take the learners, say I say X is the number of people doing physical sciences, ne? And if I say X divided by 43, right, I take the number of learners who are doing, okay, I have 43 learners doing mathematics, yes. Of the 43 learners, X amount is doing physical sciences, and in terms of probability, it's like 79% of them. 79% of them does physical sciences. So if I take X, which is the number of people taking physical sciences, I divide by the 43, the number of learners doing mathematics, I get what? I get 0.79. So when you do cross multiplication, of course this was 1, Cross multiplication will leave you with x equals to 43 multiplied by 0.79. Yeah, 0.79, that is 33.97. Right, so here this is where it becomes a bit challenging. It's not like a big issue, but the thing is, when we are talking about people, we don't have a comma person, right? We don't have comma people. Like, we either have 33 learners or 34. We either have 33 learners or 34 learners. So which one is going to be? I would say, right, there's a rule that when you're talking about people, you always round down, right, instead of rounding up. So that means we will just say that this is 33. Let me see, 33 divided by 43, that gives 76. Okay, let me see, what about 34? Yeah, I mean, it seems like actually here 34 is the one that gives the percentage of, right? So let's go with 34. Because 34 is the one that gives us 79%. 33 gives us what? It gives us 76, not 79. But yeah, okay, cool. At least here there's a clue. Like, you can see 33, it's not giving, so 34 it's giving. Yeah, cool. Let's see what we have next. So another question, they say a letter is chosen at random from the word algebra. What is the probability that the chosen letter is A, right? So you have A, you go. How many letters do you have? That's the first thing you need to check. I have 1, 2, 3, 4, 5, 6, 7. 7 letters. That's the number of letters you have. So then letter A, you have 1 and 2. So that means probability will be 2/7, right? And of course, I just want to say my answers, I've not been writing them in decimal form. Please write them as decimal form. Yeah, like, will you have it like this? Go to your calculator, press 2/7, and write 0.29, right? Cool. Please, I beg you. Yeah. And then they say find the probability that a letter chosen is a consonant. Remember, we have vowels A, E, I, O, U. Can I say them in English? A, E, O. Yeah. Okay. A, E, I, O, U. Those are vowels. So the consonants is the rest. Né? So you can just count. We have 1, 2, 3, 4. So you have 4/7. Right, 4/7, which is 0.57. Right, cool stuff. And we have another Venn diagram questions. In a class of 30 learners in grade 10, there is the following information. 5 learners, so you see we have to draw the Venn diagram, né? So 5 learners are right-handed, 12 learners play soccer, 3 learners play soccer and are right-handed. Sorry, let R set right-handed as for playing soccer. So let's get started. Started here. Yeah. All right. Cool stuff, ne? So I have right-handed, I have soccer, right? They told me that 3 plays soccer and are right-handed, so I have 3 here, ne? And then 5 learners are right-handed. That means the number here is what? Is going to be 2. Let me see how much this is. It's 5 marks for drawing. So you would say for right-handed, right? Say this. You have 5 equals to x plus 3. Then you'll get x to be 2. Right? Because these two added together, they must give you 5. And then for soccer, you will say S. They said 12 play soccer, so that is 12 is equals to Y plus 3, and therefore Y equals to 9. So you have 9 here, and the whole circle gives you what? It gives you 12. And then remember, in total we have 30 learners, so it can be like 30. we're gonna have to write it down because you need to show your workings, né? So you would say 30 minus 3 minus 2 minus 9 equals to actually equals to K, right? But what I want to do is, or I want to say 30 is equals to, you have 2 plus 3 plus 9 plus, say we have K plus K, right? And then you would start to have 30 minus 2 minus 3 minus 9 equals to K, which is what? 30 minus 2 minus 3 minus 9. It's 16, right? 30 minus 2 minus 3 minus 9, 239. So that means the number here is going to be 16. You see? So, yeah. And then when you add all the numbers, 16 plus 2 plus 3 plus 9 has to give you 30. So don't forget. Okay, since we have S here, I was gonna say S equals to 30, but since we have S, let me just say N equals to 30, right? Now we can answer these questions. The first one, they say, are the events play soccer and right-handed mutually exclusive? The answer is what? Is no, right? And the reason why, you would say no. Let me say this is number 2. You would say no, and your reason is because probability of right-handed and soccer and play soccer is going to be 3 over 30. Here's a 3 for the end, right? And they told us, or you can just say that 3 learners play soccer and are right-handed, né? And then you're like, how many learners in class are left-handed and do not play soccer? So remember, this is the circle of anyone who's right-handed, né? And there's a circle of everyone who plays soccer. So that means anything that is outside these 2 circles is people who are left-handed, because we have the right-handed circle, and people who don't play soccer. So that means the number of learners is 16. It's gonna be 16, right? And they say determine the probability that a left-handed determine the probability that a learner is left-handed and plays soccer. Yeah, this is a tricky question. It's a tricky question. The thing is, this circle, I want to highlight it. This circle, right? This circle is for learners who are right-handed. If the learner was right-handed and does not play soccer, actually we do have those people. We have people who are right-handed and do not play soccer. The number is what? 2. 2 learners, right? Here's the number 2, are the number of learners who are right-handed and do not play soccer, because 2 is not within the circle. And then learners playing soccer and are right-handed, there are 3 of them, right? So that's the end of the right-handed circle. So anything outside the right-handed circle is going to be people who uses their left-hand side, right? So that is what? That is 9 and 16. So in total, there are, if I want to find out the number of people who are left-handed, wait, how many? Oh, okay. If I want to find the number of learners who are left-handed, it's going to be 9 plus 16. The 9 is number of people who are left-handed and play soccer. Here it's number of learners who are left-handed and do not play soccer. That's why here, do not play soccer, it was 16, right? If they played soccer and they were left-handed, it would be the 9. So that means determining the probability that Elena is left-handed and plays soccer is going to be 9 over 30, which is, I think, 3 over 10, 0.3. Yeah, so do you see, without the Venn diagram, it becomes a bit challenging to answer these questions, but with the help of the Venn diagram, it becomes way easier to even visualize and see them. And with that, it will be the end of this video. I'll see you in the next chapters.